Hello, in this example, we'll look at how you can use Rafay's Array as a Service solution, and we'll look at a specific example for distributed training. We'll see how we can run the distributed training getting started guide using PyTorch. Let's get started with the documentation. You'll get access to source code, which I've already downloaded, and then there's also a job submission Python file, which is called run.py, that you'll get along with it. You can download the same file. In this example, we're going to be using Array's job submission client to submit a job to the remote Array endpoint. This remote Array endpoint is provisioned and operated on a shared Kubernetes cluster. And this is provisioned using Rafay's Array as a Service solution. Just make sure that you take the code and you update your URL appropriately and the credentials appropriately, and then you can run it. Let's see what that looks like. So I have two files here, run.py and the torch test.py, and then let's just get going on this. And when I run this is going to connect to the endpoint that was configured. And in a few seconds, I'll bring up the dashboard to show what exactly you can see. As you can see here in our Array dashboard, you've gotten a new job that is running. And if you go look at expand the job, you can see that the runtime environment has been set up with Torch 1.9, etc. And the content that we got is in this GCS location in a zip file. And then if you go look at the status, it says the job is running. And then as we look at this, we keep refreshing the data, you'll see the output coming through. This actually may land up spinning up a bunch of workers to make this happen. As you can see here, it spun up 3 workers to do the training job. And as you can see that all of them are using a ton of the CPU, and they are working in parallel to get the job done. This may take a few minutes to happen, but let's go see the job here. Actually seems like it's done. And if you go look at the output here, it spawned a bunch of workers. It in fact spawned 5. Seems like it's 5 workers, or 1, 2, 3, 4, 5 workers, and then aggregated the model parameters from all the workers, and there you have it. A very simple way by which you can do distributed training, in this case on multiple workers, and aggregate the model parameters back from all these workers, and do this at scale using something like PyTorch.